Welcome to This Explainer. Today, we're diving into something that literally sounds like it's straight out of a sci-fi movie. We're asking a massive question. Is the universe we live in actually just a giant computational simulation? We're going to unpack some groundbreaking new research that connects digital data, biological life, and the very fabric of our reality. Seriously, this journey is going to challenge how you fundamentally view the world around you. Let's get right into it.
So are we living inside a giant computer simulation? I know, it sounds like pure science fiction, right? Like we're trapped in the Matrix. But here's the wild part. Actual peer-reviewed physics might just be pointing us toward this mind-bending reality. We aren't just talking about late-night philosophical thought experiments here. We are looking at hard, measurable physics and newly proposed scientific laws that suggest the universe operates exactly like a giant hard drive trying to optimize its storage space.
We're going to start with this incredibly provocative claim from a recent article detailing the research of physicist Dr. Melvin M. Vopson. It says, gravity is not a force, but a phenomenon arising from the universe trying to efficiently process information. Think about that for a second. This suggests that what we experience as gravity, the thing keeping our feet planted on the ground and planets spinning in orbit, is actually just evidence of a computational universe optimizing its data. Now, to wrap our heads around how a physicist even makes a claim like this, we first need to completely rethink what the word information actually means.
Section 1. Physical entropy versus information. To understand how a physicist arrived at this whole simulation idea, we first need to take a step back and look at the fundamental laws that govern energy, matter, and data. Basically, this is where physics meets computer science. The crucial point here is that information isn't just some abstract mathematical concept, it's physical. Back in 1961, something called Landauer's principle proposed that creating and deleting information has a real, detectable energy footprint. Fast forward to 2019, and Dr. Vopson actually expanded this into the mass-energy-information equivalence principle. Just like Einstein proved mass and energy are interchangeable, this new principle adds information to the mix. Meaning, if mass equals energy, and energy equals information, then data actually has physical mass. It's governed by the laws of thermodynamics, just like a rock, a star, or a hot cup of coffee.
Section 2. The second law of infodynamics.
This brings us to a groundbreaking new rule of physics introduced by the researchers. Now, if information is physical, it obviously needs a law to govern how it behaves over time, right? But before we get to that new law, we quickly need to understand Shannon information entropy. This was developed in the 1940s, and it basically measures the amount of data encoded in any physical system's microstates. Think of it like a measure of how much surprise or, message is packed into a sequence. If an event is perfectly predictable, its information entropy is 0. The more complex and varied the data states, the higher the information entropy. Keep that in mind because it's super important for what comes next.
Now look at the profound dissonance between these two rules. It's wild. The famous second law of thermodynamics dictates that physical entropy, which is essentially chaos or randomness, always increases over time. Your hot coffee gets cold, buildings crumble, the universe naturally expands into disorder. We're all familiar with that. But in stark contrast, the newly proposed second law of infodynamics states the exact opposite for data. It says the information entropy of a system must remain constant or actually decrease over time. So while physical chaos is always increasing, information inherently works to minimize itself.
Section 3. Proof from magnetic data.
Okay, to make this abstract physics a bit more tangible, how do we actually prove that information deletes itself? Well, to test this, the researchers ran a micromagnetic simulation of an 88-bit digital grid at room temperature. They deliberately wrote the word information into the magnetic states using binary code. In this setup, a digital 0 is represented by the blue tiles, with the magnetization pointing into the plane, and a 1 is represented by the red tiles, magnetization pointing out of the plane. Basically, this represents a highly ordered state of information entropy.
And this brilliantly illustrates the new law in action. They just allowed the simulation to run over time. As the magnets undergo thermal degradation, meaning the physical entropy is increasing, you can clearly see the pattern breaking down. But here's the absolute secret. As the physical chaos increases, the distinct data states inherently delete themselves, reverting back to a uniform state. The information entropy actually drops towards 0. The system naturally wiped its own unnecessary data. How crazy is that?
Section 4. The viral RNA evidence.
Now, the researchers didn't just stop at computer data. They actually mapped this exact same law onto living biological systems. And this is where the implications get truly wild. I want you to think of a viral genome just like a computer's hard drive. RNA acts as a 4-state probabilistic system.
It uses a four-letter code, A, C, G, and U, to store distinct information states. Because there are 4 options, each nucleotide can encode up to 2 bits of digital information. It's essentially an organic memory stick that mutates over time. So logic dictates that if the second law of infodynamics is truly universal, this biological data should also try to minimize its information entropy over time.
Well, when analyzing the genome of the SARS-CoV-2 virus over a 22-month period and looking at different variants, a totally fascinating trend emerged. As time went on, the physical genetic mutations predictably went up, so that's the physical entropy increasing. But simultaneously, the Shannon information entropy of the virus went down in a nearly perfect linear trend. The virus was actually mutating to become more efficient, packing less random data into its sequence. It was literally auto-optimizing itself.
This brings us to a staggering conclusion from the study. The existence of an entropic force that governs genetic mutations instead of randomness is very powerful. This implies something massive, guys. For decades, we've believed that genetic mutations in biology are just completely random errors. But this research suggests they aren't random at all. They're actually driven by a fundamental physical law trying to minimize information. The virus is essentially running a compression algorithm on its own source code.
Final section, redefining gravity and reality.
So let's see how this all builds back to our original, mind-bending question about the nature of reality itself. The absolute crucial takeaway here is that across both the digital and biological realms, the universe aggressively works to delete unnecessary information and optimize its data. Whether it's the magnetic hard drive in your laptop or microscopic viral RNA spreading across the globe, the overarching rule is exactly the same. Drop the information entropy, optimize the system, save the processing power.
Which leaves us with this incredible, lingering question. Why does the universe act exactly like a computer optimizing its memory storage? If information is indeed physical, and the universe mathematically auto-deletes excess data to save processing power, and if, as Dr. Vopson suggests, gravity itself is just a byproduct of this massive information optimization happening at the cosmic scale, could we actually be living in a giant simulation? The physics are really starting to point to yes, and honestly, that changes absolutely everything about how we understand our world. Thanks for joining me on this explainer. I really hope it left you with as many thrilling questions as it did answers.